Hello and welcome to the day 2 of Azure Community Conference. My name is Janakiram, MSV. It's my pleasure to be a part of this conference. I'm pretty excited to bring you the concepts of multi-cloud and hybrid cloud through Azure Arc. So I'm going to start this session by discussing the current challenges in dealing with current IT landscape. Then I'm going to introduce what is Azure Arc and why did Microsoft invest in it. This session has 3 sections. The first section is all about Azure Arc for servers, where I'll walk you through the process of registering external servers running in multiple public clouds and on-premises with Azure Arc. The second section is all about dealing with Azure Arc-enabled Kubernetes clusters, where we will manage multiple Kubernetes clusters deployed in a variety of environments, including mainstream public clouds and on-prem bare metal environments. Finally, the third section is running data services in one of the clusters that is managed by Azure Arc. So we'll see how to deploy SQL managed instance and Postgres Hyperscale with Azure Arc enabled data services. So every section has comprehensive end-to-end demos, which will help you understand how to deal with each of these core offerings of Azure Arc. So let's get started. So enterprise IT today is more complex than ever. If you look at the developers, they are moving from monoliths to microservices. And in that process, they are targeting a variety of languages, variety of tools, environments, runtimes. At the same time, they are targeting a variety of deployment environments, from virtual machines to variety of databases to containers to serverless environment. Now your code has to seamlessly run on any of these environments, written in any of these mainstream languages and runtimes. For DevOps and administrators, they are dealing with very diverse infrastructure. There are IoT devices, there are edge devices, branch offices, OEM hardware running within the data center, co-located environments, and hosting environments, and of course, multi-cloud. So today, a lot of customers are investing in multi-cloud. They are targeting their deployments and workloads across Microsoft Azure, Amazon Web Services, Google Cloud, and other cloud platforms. Whether you are a developer or an IT administrator or DevOps professional, or even a business stakeholder, this is going to significantly impact the way you actually work. That's because, as I mentioned, developers are under tremendous pressure to move from monoliths to modern software architecture and target a variety of environments and platforms. DevOps and IT administrators have to deal with anything and everything, starting a developer's laptop all the way to the public cloud. And for business stakeholders, they have to justify their investment and the move to digital transformation by enabling cloud as the biggest factor. So this is the current IT landscape, and it's extremely overwhelming. So last year at Ignite, Microsoft has launched what is called as Azure Arc, and this is becoming the cornerstone of Microsoft's hybrid and multi-cloud strategy. And Microsoft is the only platform company that handles the entire spectrum. On one end of the spectrum, we have Azure IoT, and this is enabling customers to onboard devices that are managed through cloud. Tiny sensors, microcontrollers, to sophisticated edge devices that are running modules and business logic to ingest and to perform stream analytics is running on one side. On the other extreme end of the spectrum, we have Azure Stack, which is based on hyper-converged infrastructure. By partnering with companies like Lenovo, HP, IBM, Microsoft is shipping full-blown devices, or rather appliances, that are running a slice of Azure cloud within the customer's environment, and that is Azure Stack. Now, in between Azure Stack and Azure IoT, there comes in Azure Arc, which is bridging the gap between existing environments such as on-prem data centers, colo environments, and even other public cloud platforms which are running customer workloads in the form of virtual machines, Kubernetes clusters, and it is enabling customers to run data services on any of these environments, Now, I should also mention that Microsoft is again very unique when it comes to this hybrid and multi-cloud strategy. While there are a lot of offerings available in the market to manage Kubernetes clusters and modern infrastructure through the public cloud, Microsoft has gone a step further and enabled legacy machines running on bare metal virtual machines to be registered with the public cloud and treat them like first-class citizens of the public cloud. So that means whatever best practices you follow in managing your cloud infrastructure, they can now be seamlessly extended to on-prem and other cloud environments. Not just for Kubernetes clusters and modern infrastructure based on containers, but even traditional infrastructure running Linux and Windows servers. Now, that's a very unique strategy delivered by Microsoft through Azure Arc. So let's take a closer look at Azure Arc. Now, there are 4 things that are delivered by Arc. So Arc is essentially a set of technologies that extends Azure's management and operations capability to on-prem, multi-cloud, and even edge. And it delivers 4 key benefits. The first one, you can run data services anywhere. This is going to bring data sovereignty and data locality by running SQL workloads in environment of your choice, keeping data close to compute. The other benefit is extending Azure management across the environments. Now that means whatever best practices you typically apply to cloud infrastructure, they can be extended to VMs, bare metal servers, and even Kubernetes clusters running in very diverse environments. And finally, this brings everything under a very policy-driven security context, because you can extend Azure security anywhere and everywhere through Arc. So these are the high-level promises, and these become very clear when we go through the demos and see some of these capabilities in action. So at a high level, Azure Arc addresses 3 use cases. The first one is organizing and governing across environments. You can onboard your traditional infrastructure based on VMs, modern infrastructure based on Kubernetes clusters to Azure Arc, and you can manage them from a single pane of glass. Then you can use deployment at scale by enabling what is called as GitOps. And Azure Arc has a very sophisticated yet simple deployment at scale mechanism delivered through GitOps. More on this later. And finally, as I mentioned, the ability to run data services anywhere. SQL managed instance and Postgres Hyperscale can be deployed in any Kubernetes clusters that matches the prerequisites and criteria set by Azure Arc. And after that, you can deploy a highly elastic and highly scalable and highly available database, relational database, running very close to where your data and compute are. So these capabilities are mapped to Azure Arc for servers, Azure Arc enabled Kubernetes clusters, and finally Azure Arc enabled data services. Now let's take a closer look at Azure Arc for servers. But before that, let's understand the technology behind Azure Arc and how Microsoft has extended the capability of public cloud to hybrid and multi-cloud. So if you are an Azure professional or an Azure developer, you know the foundational aspect of Azure is ARM, Azure Resource Manager. Now, this is going to be the critical building block that is orchestrating a variety of resources that are provisioned, managed, and even terminated by Azure. So every time you go to Azure and ask for a VM or a Kubernetes cluster or a Cosmos DB instance, you are essentially submitting that request to ARM. ARM is orchestrating this request and will decide how the resources are being provisioned and exposed for consumption. So ARM has a set of templates and extensions that enable automation. So the ARM templates, which are either written in JSON or YAML, can be very easily updated based on your versioning system, and you can use infrastructure as code through ARM templates. Now, ARM has well-defined resources, the VMs, the Kubernetes clusters, the database instances, everything is an ARM resource. So with Azure Arc, what Microsoft is doing is it is essentially extending the ARM capabilities and the ARM orchestration techniques to not just the resources in the realm of Azure, but even those resources that are outside of Azure, like VMs, which are servers, Kubernetes clusters, and relational databases based on Postgres and SQL. So at a high level, this is how Azure Arc is managed behind the scenes. Essentially, there are new ARM resource types meant for hybrid and multi-cloud resources, and they are treated as first-class citizens when you onboard VMs, clusters, and data services. So all the benefits of automation, infrastructure as code, security, policy-driven management will seamlessly get extended to resources that are coming via Arc. So this is one of the biggest advantages of bringing in non-Azure resources under the fold of Azure. So as I mentioned, all of these capabilities map to one of the three offerings of Arc. One is servers and Kubernetes clusters. They can run anywhere, either on your data center, bare metal servers, or Azure Stack infrastructure, or even Azure Stack Edge. And then we have multi-cloud, which is running one of the mainstream public cloud environments. So that is the infrastructure layer. Now, on top of that, you can deploy Azure Data Services and manage them through the familiar CLI or ARM automation or even Azure Portal. So, and of course, don't forget VS Code and Azure Data Studio. So all these are visible to the developer as if they are first-class citizens of Azure. So to understand this better, let's take a customer use case. So there is a hypothetical financial institution that is dealing with VM sprawl or server sprawl, which means there are hundreds of servers and virtual machines in the data center, in the cloud, that are not visible to the enterprise IT. Now, this leads to a lot of fragmentation and lack of control because the enterprise IT, first of all, they don't know where these are deployed, and second, they cannot really apply the compliance and the security policies that are essential for central IT. So the business requirements that are given to the central IT and enterprise IT is to manage a mix of bare metal Windows and Linux servers with multiple Linux distributions and multiple versions of Windows running in very disparate environments. Now, IT should be able to apply governance and security policies at scale. They should be able to perform audits to ensure that the applications and infrastructure meet certain prerequisites and conditions. And if they don't meet these prerequisites, they should be able to remediate them and apply these policies to bring everything under one umbrella, which are driven by well-defined policies and well-defined security best practices. Today, achieving this is extremely hard because there is no single pane of glass to manage Windows servers, Linux servers running a variety of versions and distributions deployed in different environments from one endpoint. Now, Azure Arc is going to enable how we can enable the mechanism of managing all these resources. So once the customer implements Azure Arc, they have better visibility to the inventory. So once you log into Azure Portal, you can actually see all the resources, all the VMs and servers that are registered with Arc, whether they are running in the cloud, on-prem, hybrid or multi-cloud, all of them are visible under one UI. And they can bring universal governance to all the servers and VMs. And they can apply central compliance, not only to audit, but also to remediate. Now, managed service providers who are handling multi-tenant environments and running multiple customers under one environment can actually use this governance technique to apply the best practices and policies to different customers with very different diverse set of requirements. So that is Azure Arc for servers, where you can attach or register external servers and VMs running Microsoft Windows or Linux servers and manage them as if they are cloud resources. So to understand this better, let's look at the demo scenario. So in this demo, I'm going to walk you through different environments where we are running our Linux servers. And then we're going to register those servers with Azure Arc through Azure Arc for servers. And then we'll actually perform an audit to understand how many of them are compliant, how many of them are non-compliant, and how do we remediate those issues to bring everything under one fold. So let's take a closer look at the environment. So I have VMs deployed in all the three cloud platforms. So what you see here is Google Cloud Platform running one of the GCE or Google Compute Engine instances called AppGCE01. Similarly, I have an EC2 instance running in the Mumbai region, and we are calling this as AppEC201. And then, of course, I have an Azure VM running in the Azure VMs environment, infrastructure as a service offering by Azure. And this is another Linux VM running natively within Azure. Now, our goal is to bring all of them under one roof and then manage all of them by applying policies at scale and also performing audit trail to understand how many of them are compliant and even enable log analytics to make sure that we have visibility into the operations that take place on any of these resources. So the way it works is we are going to have a new offering called Azure Arc enabled servers. So here you already see that I have 4 VMs. So the VM that is running within the context of Azure, Google Compute Engine, and the on-prem environment. In fact, I'm also running 2 VMs in vSphere. So you actually notice that I have AppVM01 and AppVM02. They are running on-prem on top of vSphere. So even one of those VMs is registered here. And I added a custom tag called cloud, and you see where this VM is coming from. And finally, we have an Amazon EC2 instance registered with Azure Arc. Now, this is like a single pane of glass that is giving us visibility into where our servers are running and how we can apply policies and remediate some of the issues. But how do we onboard any of these servers? Well, let's actually see that in action. So once you are within the Azure Arc for servers blade of the Azure Portal, you click on Add, and then you can either onboard servers at scale or add each of them interactively. So let's click on Generate Script. And here it is giving us some prerequisites that we need to have access to port 443 and other prerequisites. Then we click on Resource Details. So I already have a resource group called Arc Demo VMs, and this is like my resource group exclusively created for all Arc enabled servers and VMs. So I'll choose that resource group, and then I choose the operating system. So you notice that there is Linux and Windows, and obviously this resource group has been created in Southeast Asia. If I'm running behind a proxy, I can even enter the proxy URL. But all my VMs are running in environment where I have outbound internet access, so I don't need to populate this. Then we come to tags, and here I already have a tag called cloud. So I'm going to add VMware because I'm onboarding one of my on-prem VMs running within VMware environment. So once I choose that, if I want, I can even populate some of the other tags like the data center, city, state, region, and so on. Now, once I have these tags populated, I'll click on download and execute script. So this is simply giving us a bash script, which has just 3 steps. We need to download the installation package. We need to install the hybrid agent, and then simply run this command. So to understand this better, let's actually switch to our terminal window and the editor. So here, this is exactly the same command that we have seen earlier in the Azure Portal. So first step is to download the installation package. Now here, I have gone ahead and downloaded this. This is simply the shell script that has all the commands. Then we need to run this command. Now to save time, I've already gone ahead and run this. So this is going to install all the appropriate packages and dependencies required for the Azure Arc management agent. Now, once we have the agent installed, then we simply need to run this command. Of course, for that, I need to be root. So I will quickly switch to the root context, and then I'm going to run this command. All right. So now the script is essentially asking us to get authenticated. So I'm going to switch over to my browser and enter the same device code. And after this, we should be able to complete the onboarding, or rather the registration process. So it will just take a minute for the agent to register the VM. And then there we go. So it says successfully onboarded resource to Azure. Now, once we come back to our portal and do a refresh, in just a minute or two, we should be able to see the new VM, which is appvm02. There we go. It is now registered. So now we have 5 VMs coming from Azure IaaS, Google Compute Engine, vSphere running on-prem, and Amazon EC2. That's not all. Once I have all these VMs registered, I can basically come to the namespace. For example, the Arc Demo VMs is the namespace where I have listed all these resources, all these VMs. I can click on Policies. Now, this section, I can actually apply various policies to audit my resources. Now, since I cannot really create a policy now and apply and wait for it to get applied, or rather assigned, what I want to show you is an existing policy. So here, I created an existing policy to audit Linux machines that are not using SSH keys for authentication. It's very clear that 4 out of 5 VMs that I'm running, the other one is not audited yet because we just onboarded, but out of the 4 VMs that are audited, 2 are compliant, 2 are non-compliant. And those two non-compliant VMs, one is running in Azure. So when I launched this VM in Azure, I disabled SSH and enabled password. That's why it is actually showing us as non-compliant. And my other resource, which is an app VM01, which is essentially this, one of the vSphere VMs, I again disabled SSH and used password and username combination. That's why it is non-compliant. If I want, I can actually remediate, provided I should be able to fix that issue. And after that, the agent that is running inside all these VMs can even perform remediation. Now, this is an extremely powerful mechanism to not only onboard VMs on servers, but not just onboarding them, but also the ability to perform audits and even remediating those that are non-compliant. So very powerful way to manage your infrastructure running across cloud, hybrid, and multi-cloud environments. So that was a quick demo of Azure Arc for servers. Now let's take a closer look at Azure Arc enabled Kubernetes clusters. What problem does this feature solve? Well, imagine a scenario where there is a retailer with hundreds of stores that are running multiple Kubernetes clusters at the edge location. Now, every store is almost like an edge location that is running a dedicated Kubernetes cluster. And each Kubernetes cluster runs line of business applications at every store. Now, managing these hundreds of clusters from a single pane of glass and ensuring that they are compliant and they are meeting all the best practices is not an easy task. We need to ensure that every cluster is running the desired state of configuration, and every application is also maintaining the desired state of configuration. That is only possible when we register all these Kubernetes clusters with a management plane, with a control plane that is capable of deploying applications at scale and also deploying policies and security best practices. And obviously, the Azure Arc control plane is ideal for this kind of a scenario. So, based on the business requirements, Azure Arc enabled Kubernetes clusters can actually deliver all these capabilities. So the benefits customers have when they adopt Azure Arc for managing Kubernetes clusters is the ability, again, very similar to VMs, the ability to onboard and manage multiple clusters irrespective of where they are running, and then use a continuous deployment technique called GitOps, which is going to ensure that every cluster is running the same application with the desired state of configuration. And you can do that at scale. So with GitOps, we basically make a change to our configuration or we add a new deployment. It gets committed to GitHub or any other Git repo. And from that, the agent running in every cluster will pull the configuration and will automatically apply. So this is going to ensure that we have a very scalable deployment model where you commit the changes to a Git repo and it gets propagated to every registered cluster with Azure Arc. So all this is possible when you have an Uber control plane like Azure Arc that is managing all the Kubernetes clusters. So to understand this better, let's take a look at the demo. So let me walk you through the demo environment. So I have a Kubernetes cluster deployed as a part of Google Cloud, which is based on GKE, Google Kubernetes Engine. It's running a 4-node cluster in Asia South 1 region. I have another Kubernetes cluster running within Amazon AWS, and this is running an EKS cluster. I of course have an AKS or Azure Kubernetes Service cluster deployed within my Azure environment. Now, our goal is to bring all these clusters under the fold of Azure and manage them through Azure Arc. Like Azure Arc for servers, we have a process to follow, and I've already gone ahead and registered the 3 clusters, which are AKS, EKS, and GKE clusters with Azure Arc. But beyond this, I also have an on-prem bare metal cluster. So let me show you how that looks like. So here is my bare metal cluster running 4 nodes, 1 master and 3 nodes. Now we have already seen we have, for example, this is the GKE cluster running 4 nodes in Google Cloud. And then we have an EKS cluster running 3 nodes in AWS. And of course, we also have an AKS cluster that is running 3 nodes in Azure. Now, all the 3 public cloud-based Kubernetes clusters, the managed Kubernetes clusters, are already registered with Azure Arc. But this cluster is not currently registered. So I'm going to walk you through the steps involved in onboarding my on-prem cluster running in bare metal environment. So here are the steps involved. We start by creating a resource group in one of the supported regions, which is West Europe. And this is already created because we have registered the Kubernetes clusters running in the managed cloud environments. Now, once we have the kubeconfig setup, which is pointing to my bare metal server, all we need to do is run a single command that is going to register the cluster with Azure Arc. So let's go ahead and run this. Now, this is going to take a minute or two. And in that process, it actually creates a new namespace called Azure Arc and deploys an agent very similar to Azure Arc for servers, but this time we are targeting Kubernetes clusters, and that agent will connect our on-prem cluster with the Azure Arc control plane. So now the Azure Arc namespace is created. We can also look at the pods that are actually created under this namespace. So if you actually see, there are multiple pods, and all these are the dependencies and the agent that is actually running within the Kubernetes cluster, but maintaining connectivity with the Azure cloud. Now, this is the first step where we go ahead and register our Kubernetes cluster. And once this is completed, where we see all the pods are in running mode, and once the command line reports that the process has been successful, we can go back to the portal and see the bare metal cluster showing up there. There we go. So now this has been successful. So let's come back to our Azure Portal resource group, and there we go. So this is the Arc Demo Metal cluster. Now we have 4 clusters, each running in a different cloud environment, and this one running in on-prem environment registered with Azure Arc. Now that's not all. If we actually look at the other clusters, for example, let's look at the namespaces available in GKE. So in this environment, we see that there is a namespace called Vote, and there is another namespace called Guestbook. And interestingly, every registered cluster is already running that. There is a Guestbook namespace, that means an application, and an Vote application running in a dedicated namespace. Now, how is this possible? How do we ensure that every cluster that we have is running a very similar workload and similar configuration? Well, that is possible when we have GitOps configured. Now, all the clusters are already configured with GitOps. And what it means is, here we have the GitHub repo. So this GitHub repo called Arc Demo is running a simple workload, or rather it has a spec. It has a YAML file that has the popular Azure Vote application YAML spec, and I have a namespace for Guestbook. Now, the moment we connect this GitHub repo with our clusters via GitOps, any change that you make to this will automatically reflect in the cluster. Now, that is possible because there is an agent, again, for GitOps running within the registered cluster. So let's go ahead and do that. So we can also use the command line to basically query the Arc control plane, and we see that now there are 4 servers, and our goal is to enable the bare metal cluster for GitOps. So for that, I'm going to simply run this command. So we are going to create an agent for this cluster called Arc Demo Metal, and we are registering this within the namespace of Arc Demo clusters. And this is the repository URL. And let's keep the namespaces under watch, and then I'm going to run this command. It's going to take a couple of minutes, but as soon as the agent is up and running, it will reconcile our cluster with whatever is configured in GitHub. Now, in a minute, we should be able to see a new namespace called cluster config. So cluster config is the namespace responsible for running the GitOps agent. And Microsoft has adopted an open source project for this called Flux. And based on Flux, it is going to create an agent which will pull all the artifacts and all the specifications defined in the appropriate GitHub repo. All right, now we see a new namespace called cluster config, and this is currently deploying the Flux CD or the Flux continuous deployment agent. And once it is going to pull the appropriate artifacts, we'll see the vote and the guestbook namespace. There we go. Now the vote namespace is showing up. Let's go ahead and query that. So kubectl get pods from the vote namespace. There we go. So now we have the Azure Vote backend and frontend, excuse me, running within the namespace called vote. And any change that you make to this GitHub repo will automatically get reconciled with the cluster. Now that is the power of GitOps and doing this at scale with every registered cluster with Azure. So that is the second demo where we have registered Kubernetes clusters running in different environments and then used GitOps to roll out workloads and configuration at scale. Of course, when you come back to the portal, you can also apply policies. Now here, you can actually see that there are no policies, but just like Azure Arc for VMs, you can go ahead and assign a policy that is specific to Kubernetes clusters and even remediate them. So if you click on any of the clusters, for example, Arc Demo Metal, you can also configure GitOps from the portal. So here there is cluster config. So if you look at the details, it actually shows that this is the URL that is responsible for maintaining our single source of truth, which is the GitHub repo with all the artifacts. And that is going to basically make sure that you have the configuration and workloads deployed on every registered cluster. So that concludes the second demo. Now we're going to take a look at Azure Arc enabled data services in the next section. So that was a quick demo of Azure Arc enabled Kubernetes. Now let's take a closer look at the Azure Data Services Anywhere enabled through Azure Arc for data services. So apart from registering VMs and Kubernetes clusters, it's also possible for us to run two instances, or rather two flavors of relational databases in any of the Kubernetes clusters. The first one is Postgres Hyperscale, and the second one is a SQL managed instance. Now, Microsoft has defined certain prerequisites and certain configuration that's required to run these workloads, and as long as your Kubernetes clusters meet those prerequisites, you will be able to deploy the relational database environments running in any of these Kubernetes clusters. So you can manage them as if you are running them in the cloud. It's highly available, it's highly scalable, and you have a very familiar environment based on Azure Portal or Azure Data Studio to manage your database workloads. And the best thing is the billing is also visible through the standard Azure Portal interface. So let's see how we can deploy Postgres Hyperscale and SQL managed instance on one of the Kubernetes clusters registered with Arc. So let's switch to the demo. All right. So in this demo, I'll walk you through the steps involved in deploying Azure-enabled data services, Azure Arc-enabled data services in one of the Kubernetes clusters. And in this case, it's going to be our bare metal cluster. Since it's a slightly long-wound process, I'm going to walk you through the steps, but this is not installing everything in the demo. I have pre-configured this cluster just to make sure we save time. So it all starts by creating a namespace called Arc. And once the namespace is in place, we go ahead and install what is called as the CRD, or the custom resource definitions. This is already available on GitHub, so we just need to run kubectl create command, and that's going to install all the custom resource definitions. Then Azure Arc Data Services has a bootstrapper, which is going to make sure that the foundation for this service is a part of the Kubernetes cluster. So we install the bootstrapper, and this is again a part of the Azure Arc namespace. So when we actually do kubectl get pods Azure Arc, you actually see that there are a lot of agents and there are a lot of other pods that are running. So basically, that is a part of the bootstrap process. Now, once the bootstrapper is in place, we need to create a secret, and this secret is essentially a simple base64 encoded secret of the username and password. And this is going to be used when we log into what is called as a data controller. So once the secret is created, then the next step is to create the data controller. And data controller is the most critical element of the data services deployment. Now, this is responsible for managing and orchestrating the database instances, whether it is Postgres or SQL managed instance. The data controller is like the gateway, and this is going to manage the life cycle of the database instances. So it all starts and ends with the Azure Arc data controller. So in this process, in this step, we actually install the data controller. And once data controller is installed, we see the agents that are responsible for running the data services deployed within this namespace called Azure Arc, or actually the namespace is called Arc. Now this is running a lot of deployments. So there is a bootstrapper, there is the controller, and this controller is responsible for managing the life cycle of the Azure Arc enabled data service instances. Perfect. So once the data controller is installed, then we can go ahead and install the PostgreSQL database. So again, that is a standard Kubernetes deployment manifest. And again, because we installed the CRD, the custom resource definition, just like a pod and a stateful set, Microsoft has created a new type, a kind called PostgreSQL 12. Now, this is the custom resource based on the CRD definition. And we are running 3 shards. That's the reason why you actually see there are 3 instances of our PostgreSQL. We define the CPU and the memory limits and requests. Then this is exposed as load balancer. We also give the size of the backups, data, and logs as 5 GB. So that is the PostgreSQL deployment. Then we do the same for SQL managed instance. Now the SQL managed instance spec is not very different. Again, let me show you the not PostgreSQL, but SQL managed instance. So here it is. So again, this is a part of SQL managed instance custom resource based on the CRD, and it is also exposed as load balancer. Now we go ahead and deploy that as well. So if you actually query the namespace for Postgres 12, you actually see that there are 4 pods that are running. Now similarly, when we query the SQL managed instance type, there is exactly 1 instance of SQL managed instance, and it is exposed at this endpoint. Perfect. So now on a bare metal local Kubernetes cluster, we are running 2 managed databases. One is Postgres Hyperscale, and the other one is SQL managed instance. Now we can start accessing these data services by logging into the controller. For that, we need to get the controller endpoint. Remember, the controller is like the gateway. So this controller is currently exposed as the load balancer type, and it's available on this external IP address. So what I'm going to do now is to do AZ data login. AZ data is a CLI that you get when you install Azure Arc enabled data services. And it's going to ask us for the username and password that was created through the deployment. And now we have successfully logged on to the data controller. And from the data controller, we can start querying the available PostgreSQL instances. And there we go. So now we have PostgreSQL running at this endpoint. There is also a log search powered by Kibana. There is a metrics dashboard that is coming from Grafana. So all these belong to the Postgres Hyperscale deployment. Now, once I have this, guess what? I can even log in to my Postgres instance. So here I am logging on to the Postgres that is running as a deployment on Kubernetes exposed at this IP address. So now we can even query the databases and the tables that are available. So let me first switch to the DVD rental database, and then I can look at all the tables. Perfect. So now I'm actually dealing with a managed instance of Postgres running in my Kubernetes cluster from my workstation. So that's about Postgres. Now, how about SQL managed? Well, I can also take a look at the SQL managed instance list. There is only one instance, and it is listening on this IP address. So I can use the MSSQL CLI, a command line available for Mac, to log into my SQL shell. And guess what? We are accessing our favorite sample database, which is AdventureWorks. Now let's take a look at this. There are multiple tables. We can access all of them. You can run tsql commands targeting the SQL managed instance running within Kubernetes, all on your local cluster. Perfect. That's not all. You can even use Azure Data Studio to actually target this. So here is the Azure Data Studio. Now I have installed the appropriate extensions. So one of the extensions is the Azure Arc controllers. So this is the same controller that we deployed as a part of Azure Arc enabled data services. And once I configure this, I can actually see that there is a PostgreSQL instance that is running. So, as we have seen earlier, it is currently running the PostgreSQL endpoint as well as the Kibana dashboard and the Grafana dashboard. Then there is SQL managed instance. I can even manage that, and it basically shows us where the configuration is. So you can also grab the connection strings thanks to the cool UI of Azure Data Studio. Now that's not all. Based on the servers extension for both Postgres and SQL, I can query the databases. So here is the DVD rental database. I can click on manage, and it actually shows us all the tables available under the DVD rentals database. Similarly, I can explore the SQL managed instance, and here I can access the AdventureWorks interactively from Azure Data Studio. I can run queries. I can even launch a new notebook, perform backup, restore, basically take control of my databases as if they are running on my local environment. But the beauty is this is actually running as managed databases inside the Kubernetes clusters managed by Arc. Fantastic. Now it can't get better than this. So we are basically bringing databases into our own environment, giving them appropriate resources and managing the entire lifecycle locally. This is extremely powerful, and this is possible through Azure Arc enabled data services. So that concludes the third demo, where we have explored how to manage the databases installed through Azure Arc enabled data services. All right, that was a walkthrough of Azure Arc enabled data services. We are almost at the end of this keynote. Now, let me summarize what we have discussed. So Azure Arc promises three capabilities. One is the ability to organize and govern environments or resources running in multiple environments through a single pane of glass. And you can do that for both VMs and Kubernetes clusters. Second thing is the ability to manage application deployment at scale thanks to GitOps based delivery. So we have seen how we were able to roll out the same application to all the registered clusters with Arc through a GitOps based agent, which is Flux. And finally, the ability to bring managed databases running in any environment, whether it is on-prem or public cloud, and get the same security, high availability, and scalability without compromising on data sovereignty and data locality. So this is bringing the promise of managed databases to an environment and infrastructure of your choice. And that is Azure Arc enabled data services. So that was Azure Arc, delivering the promise of hybrid cloud and multi-cloud. So that concludes the keynote. Thank you for joining, and thanks to the organizers for putting together this fantastic event, bringing all the developers and all the speakers across the world and giving us an opportunity to interact with you. So if you have questions, reach out to me on Twitter. You can see my coordinates on this slide. Thanks once again and have a great conference ahead.